This question is from GATE Mechanical Engineering paper of 2019. This is question number 9 of set 2. The question is a two-dimensional incompressible frictionless flow field is given by u vector is equal to xi cap minus yj cap. If rho is the density of fluid, the expression for pressure gradient vector at any point in the flow field is given by. Now we are given 4 options here, among which we need to choose the correct expression for pressure gradient for the vector field u vector is equal to xi cap minus yj cap. All type of fluid flow are governed by Navier-Stokes equation. So let's write the Navier-Stokes equation. Navier-Stokes equation. The Navier-Stokes equation for incompressible flow in vector form can be written by the incompressible Navier-Stokes equation in vector form can be written as dou u by dou t, this u vector plus u vector dot del into u vector is equal to kinematic viscosity del 2 of u vector minus pressure gradient divided by the density plus the acceleration due to gravity. Now here this equation is for incompressible flow, that means del dot u vector is equal to 0. Please mind that del dot u is not equal to u dot del. Please remember this equation. Now in the problem it is not mentioned that the flow is unsteady, so we will consider the flow to be steady and this term will become 0. Also it's a non-viscous flow, that means the kinematic viscosity will be 0, hence this term will also goes to be 0. Also in the problem it's not said that we have to consider the effect of gravity, so we will take this gravitational term to be negligible, or we can neglect this term, we can write it as 0. Now this was one of the form of Navier-Stokes equation. It can be written in other forms, but the final result will remain same. When we consider the viscosity in the Navier-Stokes equation to be 0, this is also called as Euler's equation. So this final equation we can write down here. What we get is u vector dot del to u vector is equal to negative of gradient of pressure divided by rho. This can also be written as rho u vector dot del to u vector is equal to negative of pressure gradient. Now since this is a vector equation, what we can do is we can separate the moment this equation in x and y direction separately, or we can write it here itself in one equation. So we can, let's write it here as rho. Now this term u dou u upon dou x plus v dou u upon dou y, and this is in x direction, so let's write I cap plus v dou v by dou x plus v dou v by dou y j cap, and this is equal to minus del p. So this gradient of p, this can also be separated in x and y direction. So grad of p is always a vector quantity. So this total is a vector quantity here. Now at this moment you can pause the video and try to find the solution by yourself using the concept explained here and the given values in the problem. Now let's continue to solve this problem. So in the problem it's given u vector is equal to xi cap minus yj cap. Now here, from here, the velocity in x direction, that is small u is x, this is small u, and this is the value of small v. So if we substitute this value in the above equation, we can write it as grad of p is equal to negative rho multiplied by u. So u here we can write x into derivative of x with respect to x, and derivative of x with respect to y will become 0, so let's not write it here, and this is I cap, that is in the x direction, plus now dou v by dou x, so v is the function of y only here, so differentiation of y with respect to x will become 0, so let's not write this term again here, and now let's find this term. So v is minus y, and this dou v upon dou y, so dou upon dou y of minus y, and this is j cap. This will be equal to negative rho multiplied by x into I cap, and this is negative y into minus 1 j cap. Fine. So finally we will get grad of p is equal to negative rho x I cap plus y j cap, and that is our final answer. Now let's match the value of grad p with the given options here. So we see that option B is the correct choice. Negative, that is gradient of P, pressure gradient, is equal to negative of rho x I cap plus y j cap. To gain more information on this type of problems, the Navier-Stokes equation or the Euler equation, you can follow the NPTEL course in Advanced Concepts in Fluid Mechanics by Professor Suman Chakravarti of Department of Mechanical Engineering, IIT Kharagpur. Hopefully I was able to clear your doubt. Have a great day. Thank you.